All right, let's go ahead and get started. So again, hello everybody, and welcome to today's webinar presentation titled Kubernetes Identity and Access Management Made Easier with D2iQ, brought to you by D2iQ. I would like to introduce you to our presenter today, Tommy Scherer, who is a senior sales engineer at D2iQ. And Tommy supports the Western region for D2iQ, and he has been working with cloud-native technologies, including OpenStack, Swift Object Storage, and Kubernetes since 2009. This time, I'd like to do a quick sound check for Tommy. So Tommy, please say hello to our audience, and audience, let me know if you can hear him.
Hi, good morning, guys. Can you hear me?
Sound great on my end, and it looks like the audience can hear you as well. And at this time, I'd like to pass it off to you, Tommy, for your presentation.
Perfect. So kind of what the plan was today's webinar is to kind of briefly go through a handful of slides, talk about the D2iQ Kubernetes platform, and then really deep dive into our single pane of glass multi-tenant platform that we call Commander. So I'll get through this. So if we look at our D2iQ Kubernetes platform, we start at the very bottom. So our founding members were also founding members of the Cloud Native Computing Foundation. So we have that ability to train individuals. So a lot of times if you buy Kubernetes training, either that's being provided by D2iQ badged employees or Day2 badged employees trained to the trainers. We also have expert services. So the nice thing with our platform is you don't require services to get it off the ground, but if you are truly working through a digital transformation, we can assist with that. Professional services to stand up clusters, federate clusters, go multi-cloud, and really allow your operations team get that hands-on experience to be able to run Kubernetes day to day. We also have our own flavor of Kubernetes. It's pure upstream open source Kubernetes that is blessed by the Kubernetes community, the CNCF. And most importantly, what we do is we add a lot of those Day2 add-ons. So as you know, Kubernetes is more or less a commodity at this point. You can get it from multiple different places. You can download vanilla Kubernetes. You can get managed instances from the hyperscalers. We really need those Day2 add-ons to make it functional. You need things like an ingress controller, things for alerting, things to back up the cluster, things to look at logs. And then we also integrate our distribution with GitOps built in. So point it to a GitOps repo. We can assist with that continuous deployment of your applications. Layered on top of this build phase or convoy or Kubernetes, we bring something called Kudo. So this comes from our deep roots in advanced data services. Some of you may know the company as Mesosphere, and we really deployed advanced data services in containers before anyone else was doing this. So advanced data services like Kafka, Cassandra, Spark, we make it very simple to deploy these. Kudo is the Kubernetes Universal Declarative Operator. This was developed within our organization, and we donated it to the CNCF, so they're maintaining it. And then another add-on that we add on top of Convoy is Captain. So this is our end-to-end machine learning platform. It's built around a project called Kubeflow, but Kubeflow as a project needs a lot of tools around it, like a service mesh provided by Istio. Needs something for continuous deployment, so we deploy Argo alongside that. And then we can also access things like Jupyter notebooks directly for it. So data scientists aren't concerned with building a Kubernetes environment. They're not concerned with the YAML files. It's truly a notebook-first approach to data science. And those data scientists also have access to those advanced data services. So maybe you want to trickle some machine data into Cassandra. So trickle data in through Kafka, store it in Cassandra, and then you want to do some advanced analytics with Spark. You can do that all directly from a notebook. What we're going to talk a lot about today is Commander. So Commander is our multi-cluster management. Gives you centralized governance, observability, has some really neat tools around cost management and workload sizing recommendations. And it's built from the ground up to be multi-cloud, enables hybrid cloud, and also allows for multi-tenancy. So if you're trying to deploy this within even a managed service provider, tenants can be completely isolated, or even within larger organizations where separate lines of business need their own access to clusters, resources, and most importantly, quality of service. We back all this up with our expert full stack support. So we support the product 24/7. We're not just supporting Kubernetes, we're also supporting those day 2 add-ons. And most importantly, we give you the same experience, whether you're deploying in public cloud, or you're deploying on bare metal in a data center on your own servers. If you want to deploy within a virtualized environment, KVM, VMware, we have provisioners built for vSphere. And then what's really interesting is moving into edge. So we're seeing a lot more intelligence being put at the edge, lots of data being created at the edge, then also devices that might not always be connected. So 5G enabled devices that need to communicate back to a central data center at a certain point, but need some intelligence on the edge to process logs, store data. So we're seeing everything from very lightweight ARM devices like Raspberry Pis, all the way up to full-blown GPU computing at the edge. And then where we have a lot of traction, especially with our security-conscious customers in the federal government or DoD, is the ability to deploy our solution in an air-gapped environment. So we can take Commander, we can take Convoy, all of our data services, even our end-to-end machine learning, package it up as a single binary, deploy that in air-gapped solution, and also manage that life cycle of the cluster. So we bring all the dependencies needed for the operating system, for the container runtime environment, for Kubernetes, all those images for those day 2 operations. And we have a ton of experience in this, so we're very comfortable supporting that as well. So talking a little bit about what's part of those day 2 add-ons, is we really build this platform for a secure day 2. So not only are we doing vulnerability scanning for the underlying container runtime environment in Kubernetes, but we're also looking at all these projects that we deploy alongside Kubernetes. So Prometheus for alerts, Commander uses Thanos to bring all those alerting together. We have Grafana dashboards. We're using MetalLB for load balancing. We're using Traffic for a layer 7 load balancer. And then we also have kind of an optional stack here. So some of you may use Splunk. We come out of the box with a logging stack, so Kibana, FluentBit, Elastic. We have GitOps built in, so Argo and Tecton. Now we also have at one level higher in Commander that ability to build a continuous development pipeline within projects, which we'll dig into projects in a moment, using Flux. We are a CNCF embargo partner. An example of this is in March of 2020, we found a high and critical vulnerability in the memory subsystem of Kubernetes. We were able to give our customers a patch within 24 hours. We couldn't give them a ton of detail on why they wanted to patch it, other than you should really patch it. The community didn't raise the embargo on that patch for about 6 months. So if you're thinking Kubernetes, why enterprise Kubernetes? Security is a huge part of that. Every single one of our builds is continuously scanned. We're committed to fixing security issues promptly, and we also prefer stability over the newest major release. So our version is we're deploying 1.8, which has Kubernetes 1.20. So we're about a month or two behind bleeding edge. That gives us time to bring it in-house, do scale testing. So monthly we bring these builds in, and we spend about what you would get a 7 Series BMW for. So we run Twitter-sized workloads. We're running 6,000 services across 4,000 pods, 1,000 Spark jobs simultaneously across multiple data centers, 6 million messages per second in Kafka. So peak loads that you would see within a Twitter or an Airbnb. So what we went out to really solve with Commander is, even within organizations, you might have multiple different Kubernetes flavors. You might have deployments across multiple clouds. You may have this in multiple regions. So we really seek to bring federation to these clusters, so that ability to create role-based access control, resource limits, governance, and apply those to clusters as they're immediately attached. And then also give you that ability to have multi-tenancy and distribute these projects and applications globally. So what we really went out to solve with Commander are kind of fall into two pillars. So one is multi-cluster management, and the other is multi-tenancy. So when you're talking about multiple clusters, a very important part is cluster lifecycle manager. How do you update the cluster? How do you grow the cluster? How do you make sure that you have enough resources? So cluster lifecycle operations is critically important. The other thing is when you're talking about multiple clouds, hybrid cloud, multi-cloud, there's even costs associated with private clouds, is giving you that financial visibility. Figure out in real time what a Kubernetes workload costs. Break it down on a per project basis, per namespace basis, and give you those real-time workload sizing recommendations. The other thing is cost optimization. You might find that developers are requesting too many CPUs, too much memory, maybe too fast a storage for what their workload really is. So we really seek to give you workload sizing recommendations. And most importantly, observability is you need that alerting, you need those dashboards, you need logging is very important. And the other piece is what we're going to talk about in detail today is multi-tenancy. So that ability to control user access, use multiple means of authenticating, whether it's LDAP or OIDC, or even local users. Governance, so that ability to set those policies and obtain consistency across applications. And then as your users attach clusters to that central pane of glass, making sure that all that governance is applied immediately. And then application management, so that ability to deploy applications across environments, manage the lifecycle of applications, and then even deploy advanced data services from a central pane of glass. Just to give you an idea of the workload testing we do. So I talked briefly of the workload testing we do around Convoy. We also test the commander, so 95 connected clusters, 76 workspaces, 20 federated clusters, multi-cloud. So today we're testing across AWS and Azure. And then we're also testing multiple regions within those cloud providers. All right, so let's jump into to the UI. So this is our hosted environment. So internally we have an SRE group that builds us a cluster. They also maintain it. They do a great example of showing the multi-cloud abilities of this product. So this is the global workspace. So this is kind of the default view you see. We can click into clusters. We can see that we have the actual cluster that Commander is running on. Commander is a Kubernetes-based application, so you can run it wherever you want, basically public cloud, private cloud. It's not as a service. You actually run it on some sort of Kubernetes infrastructure. The clusters that we have attached here, we have an AKS cluster, we have a GKE, so Azure, Google. We also have an AWS cluster. And then we also have kind of some new clusters, which are Convoy deployed. If we click into workspaces, we can get an idea of what we have deployed and what users we have utilizing this cluster. What's also very interesting about this cluster is for identity providers, corporately we use one login. So this integrates with our OIDC provider. We use Kube OIDC to authenticate users. And then we've created groups for each one of the users within this cluster. I have an example of another cluster where we used LDAP, where we'll actually deploy an application today. So here's an example of an on-prem cluster. So for this, we'll actually run through a demo of deploying some advanced data services. The identity provider that we have for this is internal LDAP. We have a single group here for administrators, and we're actually signed in with that administrator user. So if we go back to our dashboard in this, we have a few different clusters here. We're actually doing some development work with K3s running on ARM-based CPUs. We have an Ubuntu cluster, and we also have the host that it's deployed on. So if we go to default workspace and actually create a project, we can create a new project. We'll call this truck demo. So what we're actually going to do is deploy a mock application that has some self-driving trucks that trickle data into an API server that communicates with Kafka. We then use Zookeeper to keep quorum, and then we store that data within Cassandra and then visualize it using a web UI. And all this is deployed using Flux and continuous deployment through the project view within Commander. Let's call it truck demo. We'll manually select our clusters. We'll grab our on-prem Ubuntu cluster, and then we'll create our project. Oh, looks like I've already deployed one truck demo, so we'll call this truck demo 2. Oh. Just a second. All right, so we've deployed our truck demo 4. We can continue to the project. And now what we can do is deploy some platform services. So these are deployed within the underlying cluster. These are all written in Kudo. So it makes it very straightforward to deploy what would typically take quite a long time to bring up a highly available Cassandra platform. So this is going to deploy 3 pods at Cassandra, so it will be highly available. And then we can deploy Zookeeper alongside of it to keep quorum for our application. And then we can finally deploy Kafka. And now we have our 3 platform services deployed using Kudo. So the next thing we can do is create a config map, also something that's typically a pain within Kubernetes from the command line, but we make it much simpler. So we grab a name for that. We add some key value stores. So one's going to be for the API. So this is the API of the load balancer for your cluster. And then we add one for Kafka and one for Cassandra. So this allows those 2 platform services to communicate with each other. And now we can create our configuration map. So now the next thing that we need to do is point to a GitOps repo. So this is using Dispatch, which is our tool for continuous deployment. We know a lot of your clients and prospects and our customers have made some sort of a decision around CI. So it might be Circle, it might be Jenkins, but the CD is what we really seek to solve. The CD is significantly harder to deploy. So kind of a couple options here. You can either use a GitOps source or Helm releases. So your choice there. You can basically just put YAML files within a GitOps repo that you can install either in deployment format or Helm charts. So we're going to add a GitOps repo. We'll call this truck demo. Use this. We have a couple branches for this project. One of them is main, designed for x86. And we also have some options that are compiled for ARM. So in this case, we're running on an x86 cluster. So we'll save that. And now what we can do is jump back to our command line and take a look at the pods. I think I'm pointing to the wrong cluster, so let me just apply my kubectl. So this is our Convoy CLI. It's a wrapper around it. So what we're going to do is look at our local admin.conf file, grab our kube config, and force an overwrite. So I think I was communicating with a different cluster this morning. So now we can just rerun that command. And now we see our pods running. So we have our Cassandra, we have our Helm controller that was deployed by Flex, Kafka, which is part of our platform services, and then we have these self-driving trucks. So now what we can do is grab the service endpoint for our self-driving truck UI. All right, so it's sitting on 139. And what we should be seeing are some trucks that show up. Sometimes the trucks drive a little quickly and go straight to the endpoint. So what we can do is we can create or redeploy the trucks. I think I'll pause here, and I think we have a couple polls, so we can kind of see what you guys do with Kubernetes in your environments.
Okay, we'll give it about 15 more seconds here. So please get your answers in, and then we will take a look at the results. All right, so it looks like 75% of the attendees do have Kubernetes in production, Tommy.
Very good. You guys are a very advanced group. I like to see that, and it's exciting to see in the community. You know, Kubernetes is very fast moving. You know, they add a lot of features. They deprecate a lot of features. I'm glad to see that a lot of you guys are in production.
Perfect. Would you like to move on to the second poll question as well?
I think so. Yeah.
And we'll give this one a good 20 more seconds. So again, please get your answers into the question on the screen, which reads, do your organizations have Kubernetes workloads in multiple clouds, public or private? Okay, we will go ahead and close this poll now. And the results show that most of you do not have Kubernetes workloads in multiple clouds, which is an interesting switch.
It is interesting, and that's very common for what we're talking about. Talking to our customers is deploying Kubernetes in production is a thing now, but when you're trying to go hybrid cloud, multi-cloud, it can be challenging. Kubernetes is definitely the right approach. It's the only common currency between all the hyperscalers and private infrastructure, but that's what we really want to seek to solve with Commander, is giving you those tools to move workloads around, deploy workloads across clouds, and allow you to really choose where the best place to run your application would be, whether that's in the cloud, on-prem, or even within a specific infrastructure within those hyperscalers.
Perfect. And we do have one more poll question, unless you wanted to save that towards the end, Tommy.
We can save that one towards the end. I think
Perfect.
that'd be good. Yeah, so let's go to questions, and then we'll finish with the final poll.
Okay, perfect. So if you have questions for Tommy, please go ahead and put those in the questions panel so we can get to them. And we do have a few already that we're going to go get started with. So the first one of those, Tommy, is what distributions of Kubernetes can be attached to Commander for management?
That's a fantastic question. So we built Commander to communicate with our cluster endpoints using Kubernetes APIs. So anything that is a CNCF certified distribution, so it could be vanilla Kubernetes, we've worked with microK8s, K3s, so a lot of the CNCF certified, or all the CNCF certified Kubernetes distributions will attach. And we also support the managed instances, so EKS, GKE. So a lot of those that the hyperscalers provide are also CNCF certified and compatible with our platform.
Awesome, good to know. I've got a second question here for you that reads, what would be the advantage of running a Kubernetes cluster in the cloud versus using something like EKS?
That's a great question. So when you're relying on a hyperscaler, Kubernetes might not be their number one priority. So in the case of Amazon, they have lots of different projects and products. Really, their goal is to get you to buy more compute, more networking resources, more storage. So providing Kubernetes is just a means for you to consume more of those resources. So EKS provides that control plane. It's very cost effective, but you lose some of the control of that cluster. You're also interacting with Amazon support, which our customers have had challenges with. So it might make sense to move that control plane to something that's a little bit, better supported. Also with Kubernetes, it's a fast-moving community. They add features very quickly. They also deprecate features. Having some control in the life cycle of your cluster. Our organization supports up to 3 versions back of Kubernetes. So if you deploy our version of Convoy that's 1.8 that has Kubernetes 1.20, we're going to support you all the way back to 1.17. So 1.20 was a big release. They deprecated Docker as a container runtime environment. It was fine for us. We've been using Containerd for a long time, but that could be a large shift for a lot of organizations. So a lot of it has to do with that flexibility. The other thing of deploying your own Kubernetes cluster is now you leverage maybe bare metal instances within a hyperscaler that have direct attached NVMe drives. You can either use a local volume provisioner or something that can take advantage of those local drives like a Portworx, and then you're not paying per IO for EBS or provision storage. So you might be able to reduce your cost for a given workload. And that's actually something that we can show within the cluster is our cost allocation. So we get a breakdown of costing on a per namespace basis, breaks down to memory, CPU. It also gives you an efficiency score. Are you using the right size instance? This also works for on-premises infrastructure. So if you know what you pay for CPU memory and price per gig of storage, you can plug this in and do a real-time analysis of your given Kubernetes workload, and you can make a decision. It might make sense to run your data-intensive workloads, advanced analytics, AI, ML, GPU workloads. It might make sense to put those in a data center on your own hardware. But workloads that need availability and need to be deployed across multiple clouds, access to lots of networking, that might make more sense to deploy in a hyperscaler like a Amazon or an Azure. We can also give you an idea of savings. So cluster nodes that can be right sized. So we're grabbing nodes that are too large. We're not utilizing everything. We're underutilizing nodes. So these are things that you can look at from an operations perspective and right size your environment, make sure that you're using resources the best way. And at the end of the day, set resource limits at a per project basis, and also make sure that you can give your end users the right experience, the right level of performance, but run more workloads on the same piece of given hardware.
Awesome, super informative. And it looks like those are all the questions that we have right now. So we'll go ahead and launch this third and final poll for you all. Keep in mind that this one is a select all that apply. So again, take about 30 seconds here to get your responses in, and then we will go over the results. All right, about 5 more seconds here. Okay. Interesting. Tommy, what do you have to say about these results here?
Again, this group is pretty advanced. Deploying advanced data services in Kubernetes is difficult. So Jenkins is a very popular CI solution, um, fully compatible with our CD, Kafka, Cassandra, Elastic. Yeah, lots of advanced workloads. That's good to see.
Great. Well, it looks like that's all we have here on our end. So with that, DZone would like to thank you, Tommy, for a phenomenal presentation. DZone would also like to thank D2iQ for providing our audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, everyone.
Thanks.